Thank you very much.
Welcome.
Okay, now we're recording. Awesome. There we are. Okay, cool. Can you all see my screen there? Cool. So if we were writing this out longhand, we might write something like this. We'd have an array of names, and we would print each one individually. But this is duplicated code, right? When we have duplicated code, it makes sense to use a loop instead. So since we know that we can create a loop that goes through the values 0, 1, 2, right? If we have I here, each time it goes through the loop, it's going to have a different value. The first time it goes through, it's going to have the value 0. The second time, it's going to have the value 1. The third time, it's going to have the value 2. And then it's going to stop. Because as soon as I equals 3, this condition becomes false. And so the for loop stops running.
Mm-hmm.
So if I were to put this in here, and instead of writing names with a hard-coded number, I write names I. As it goes through the loop with each iteration, it's going to change the value of I so that it's referring to a different element. These are equivalent. Okay, so the trick in order to set up the for loop in the appropriate way is A, you have to start at 0. Why? Because arrays start at 0. That's the first index. What's the second thing? Well, we have to go up by 1. Why? Because array indices go up by 1. Now, why 3? Anyone tell me why I less than 3 is important?
Because you only have 3, so it'll never get higher than that, right?
Right. So if I not only not will it never get higher, but if it even equals 3, right? If I is equal to 3, this condition is false. So what that's going to mean is that it's not going to try to call console log names 3, which is good because there is no names 3. There's only names 0, names 1, and names 2. Now that's convenient for here, but we might have an arbitrarily long array that we're dealing with, and we don't want to be having to hard code that in all the time. So instead of writing 3 here, let's write names.length. No matter how long names is, the last index in names is always going to be the length minus 1. So as long as we're going up by 1 every time, this condition is going to stop us after we hit the last element in the array. And this is true for whatever our code is. It actually doesn't even strictly matter what we do here inside the for loop. We can print stuff. We can like make a combined string of things. Let's try that. So if instead of printing out the name, I take this string concat and I add names I. If I were to console.log concat, what would I see? Jesse, what would I see?
You would see plus names I. So you would see whatever index, right? I really don't know.
Okay. You understand what I'm doing with this line?
Concat, yeah, so you're going to add them together somehow.
Mm-hmm.
So is it just commas, or is it going to be one big name?
One big name. There's no other spaces in here. It's just the previous value of concat plus the new name.
Okay.
So as we increase I from 0 up to 3, each time, instead of printing out names I, we do something else with names I. Specifically, we take names I and we pop it onto the end of this variable called concat, which started out as an empty string, but by the end, it's going to be everyone's names smushed together. Okay, let's look at another example. This time, instead of concatenating all the names, let's get the sum of the lengths of every name. Okay, so how would we do that? How would we get the sum of the lengths of every name?
We first need to get the length of every name.
Okay, so we need to do something with names I dot length. And then what? What do we need to do with that?
Add them all together.
Okay, cool. So how can we do that? How can we add them all together? You're correct. How do we do it?
Can you do
Lengths or
Well, hold on, guys, one at a time. I think Kelly was first, then Dana, you can help her if she needs help.
oh, can you do names I dot length like plus equal to names I dot length?
We want to add across each iteration. So we need to use something that exists outside the loop in order to do that. Right? What happens in the loop stays in that loop. We can't just like do something with names I dot length within that iteration and then have it be available on the next iteration. We need to take advantage of a variable that's outside the loop. This is a very important idea that comes up called having a memo value. Anytime that you have like a value that's kind of independent of your loop and is not part of the iteration, but that you use as you iterate through the collection, that's called having a memo value. So in this case, in the first case, our memo value was concat. Every time that we iterated through the array, every time that we looked at a specific element, we referenced this variable concat that had been defined outside of the loop. So we're going to do the same thing with adding together the lengths of the names. This time, our memo variable is going to be sum. We can't add each time together directly, at least not without doing some fancy mucking around with the value of I. But we can add each length to sum. Right? If I have the value of sum, and then I add the length of JJ, what's the length now?
2,
2. And then what if I add the length of Zach to that?
6,
And then if I add the length of Dana to that?
10.
So although we're not adding together the length of each name directly, we are adding them all into this one place, sum. And so the sum of all of those values is going to be available. So let's try that. Okay, let's read through this in English. We're going to start out with the sum of nothing. We're going to go through every name one by one. As we go through each name, we will take the length of that name and add it to our sum. I'll write that one in here as well. So that's the pseudocode version of that. I feel like some of you are making a face like I want to ask a question.
No, this stuff
Welcome
like
back.
generally makes sense at the time, but when it comes back to trying to like refer to these little tricks that they go over during the day, I forget exactly what we did. So I'm trying to like look at them and memorize them so I can come back to them later on.
Well, don't try to memorize them, but think about this pattern, right? We loop, starting with the sum of 0, we loop through each name, and for each name, we add the length of that name to the sum. This is an English explanation of it, right? This line had to do with looping and saying, for each thing, we do this. That's what translates over to the for loop, and this names I. That's what this is equivalent to. All right, let's come up with another problem. Can anyone think of a problem that might be similar to this? What would be another kind of problem that would be like this one? Not necessarily involving names. Tom?
Summing the items in, like the cost of the items in a grocery cart.
Sure. Yeah, that's a great example. If we wanted to sum the cost of items in a grocery cart, we would have to go through each item in the cart, take the price of that item, and add it to the total. That's a great example. Can anyone think of another example? It doesn't have to involve summing things up, necessarily.
All the films in your array that might begin or end with a certain thing, or what else could we sum? I keep thinking about the homework.
Okay. Well, that would be a little bit different, but it's not that different actually. For these two previous examples, the memo that we were using was either an empty string or a variable, a number. Well, they were both variables, but the first one was a string and the second was a number. We can also have that memo be an array. Then we could grab this results array from within the for loop, and each different element could touch it and interact with it in some way. So let's try this. What if I were to say, if aims I dot length is greater than 2, okay, so I'm going to explain in words what this is doing.
To loop through, check the length of the name. If it's greater, it's going to push it into the array you created as the memo, the results array.
That's correct.
And it will be added.
So then what will that tell us about the contents of results? What will be the values inside that results array when we're done?
Zach and Dana?
Zach and Dana.
Zach and Dana. That's right, because both of those names are longer than 2. So this is another example of the same basic pattern of having a memo value that you modify each time that you go through the array. Or I should say, rather, each time you go through the loop with every element that you look at in the array. There are lots of different ways that you can change this pattern. What if I change the condition, right? I could say where names, instead of names.length, maybe I want to look at the first character. So if you guys remember slice from yesterday, slice allows you to pull out a piece of a string or piece of an array. You can call it for both strings and arrays. So if I say slice 01, that's going to get the first character out of the name. If I then test, is that first character Z? Then my results array has only one matching name. Zach. Zach is the only name that passed the condition on this if statement. And so we were able to add it to results.
A little bit confusing because I thought slice, when you did the 01, would just slice off like the first name out of it, not the first letter of the name.
Well, we're not talking about the names array. We're talking about the ith element of the names array. In other words, names I is not the collection of names. Names I is one single name.
I got you. Okay.
Yeah. If we had a variable, we could call var current name. Then maybe this becomes a little bit more semantic. Okay, let's think of some more scenarios. What are some more similar problems? We had the grocery store checkout one, right, where we were adding up the prices of the items. Are there any other problems that we might address in a similar way? Okay, well, what if we didn't want to cut down our list at all? Let's say that instead of cutting our list down, we wanted to just transform it, like perform some operation on every name, and then add that to results. So I could say results.push current name dot to uppercase. So what's going to happen this time? Zarela, what's going to happen this time?
It will wait. So if you have the push, I guess it's like if you have a new element, it will push it there, and it will whatever the string is, it will make it have an uppercase and put it inside of the empty array.
Okay, so what will results look like at the end of our program?
Not sure.
Okay.
All three of them should be in there, right?
Sorry?
Shouldn't all three of them be in there since they already are all uppercase?
That's right. All three of them are going to be in there, but they're all going to be uppercase. The reason that all three are going to be in there is that we're pushing something into results every time. Well, what we're pushing isn't the name, it's the name uppercase. So if we run it, we get all caps. Same basic pattern, small modifications. Programming isn't about memorizing, it's about pattern recognition. Okay, it's 5:15, so let's change gears. Other topics, branching and making commits. So those were some big ones, talking about Git, using Git. We had a special request for undoing changes in Git. Okay, the thing to remember about Git is that every commit represents a moment in time. Have any of you seen like Back to the Future or played video games like Legend of Zelda: Ocarina of Time? Things where time travel's involved. Any sci-fi geeks, maybe? Cool. So you can imagine a Git history being like well, history, frankly. Every time that you make a commit, it's an event in history that's taking place. By using git checkout, you can actually jump to any moment in history. Yeah, right. Okay, so that's what git checkout is all about. It allows you to jump to any commit or any branch. Now, what's a branch? Well, in this kind of analogy, a branch, you can think of it as representing a parallel universe, right? That's one kind of time travel theory, right? That when you go back in time and you change the past, you don't destroy your original universe, you create like a new offshoot universe, right? That is what branches represent. Each branch is like a different parallel universe. And you can switch between those just like you can switch between commits. But branches are special because what happens is that if you're on a branch, if you have a branch checked out and you make a commit, that commit is going to get added to the end, to the whole tail of this chain, and then the branch reference will move from where it was to the new commit you've just created. A branch is just a movable reference to a commit. But while you have a branch checked out, every time that you make a commit on that branch, the branch will refer to the last commit on that chain. Okay. So that's how branches and checking out kind of work at a high level. But what if we're not on a branch? If we go back in time to a previous commit using git checkout and we just start coding, we don't create a branch. Well, we're no longer checked out on the branch that we were on before. We're not on any branch, in fact. And that's what's called headless mode. It's called headless mode. It's a joke, I guess. There are so many jokes in programming. Head refers to the read-write head. It's where you are within the history of Git. That's head. The head is you. I am here, right? When you're in headless mode, that means that head is not attached to a branch. That's all that is.
Can I just go back to the checkout concept again?
Yes.
So basically, I'm on a branch, provided I'm on a branch. Every time I check out, then that branch ends at that commit. Is that what you're saying?
The branch, let's say the branch already ends at a commit.
Okay.
If you check out another branch, head is going to move. Actually, this might be helpful with a picture. Okay.
Which is, yeah.
So, here's a commit, right? Here's some more commits. And let's say this is the master branch. And let's say that's where we are. This is the I am here of Git, head, okay? Now let's say that I go back in time. I check out commit over here, commit 2 or whatever. When I do that, what happens is it moves head. But now head doesn't point to a branch. Head just points directly to a commit. So that's why that's called headless mode. It just means that you're pointing directly at a commit instead of pointing at a branch. So why is that important? If I were to make a commit from here and try and modify history, that commit would not be on a branch because I'm not on a branch right now. Head would still be updated to follow it. You can almost think of head as like a meta branch. It's a branch that can refer to other branches or to individual commits. You can make a commit. You can go back in time and make it. But let's say that you're here and you check out master. What happens to head?
It moves over.
Moves over, moves back to master. So now head's on master again. Okay, how do we get back?
Connect? How do we
How
connect?
do we get back to this place?
Do we go back to him and create a branch?
Well, we could go back here, but how do we get back to this commit specifically?
We check out.
Check out, yes, but how do we know which one to check out? How do we know what commit that is?
You have to memorize the number.
Yeah, that sucks. Let's not do that. Yeah. You can still check out a commit even if it doesn't have anything that's pointing to it, but it's a pain, and you actually have to look it up by its unique identifier, as Dana just said. So if you're doing something like that, before you leave, make a branch. Save yourself some headache. Move that camera up. See that?
So in that example, I would need to rewind history, make a new branch
Yes.
before committing.
You don't even have to strictly do it before you commit, but it's a good practice. You just have to make a new branch before you leave. Otherwise, you can't get back.
Okay. So I can mess up, make the commit, and then go, oops, I need to make a branch here.
Yeah. Mm-hmm.
And then what do we do?
Well, once you've made the branch, you can leave and then come back anytime.
How do we make a branch?
So there's two ways to make a branch. Just to create the branch, you can just type git branch followed by the name that you want your branch to have.
Okay.
That's just going to create the branch at your particular commit. But if you want to create the branch and check it out, which is usually what you want to do, then you would do git. Do you see this? Is this like clear enough? Let me move this light. Is that readable?
No, that made it worse. Now your light source is shining right into it.
How about now? Better? Cool. Okay. So I can either do git branch, which just creates the branch, or I can do git checkout -b for branch,
Okay.
followed by the name that I want this new branch to have.
And then, boom, I'm on a new place and time.
Well, no, at that point, you're not in a new place in time, but when you do this second command, you both have created a new branch and immediately checked it out.
Okay. Moved my head to it.
Exactly.
Okay.
What's the command, like if you're, before you're on headless mode, to go to like that commit, say its number is like 7, even though it's not true? Like,
Yeah. It would just be git checkout. If you know the code for the commit, you can always check it out with git checkout followed by the code. That
Okay.
will work. But
Okay.
you would have to like be writing down the SHA codes for every single one of those commits. I mean, granted, you could get away with writing the first 7 because with just the first 7 characters, the odds of like a duplicate or like 2 things having the same name is like 1 in 10 billion or something like that. So it's pretty small.
Hey man, can I just interject for 1 second? Can you
Hey, Tom.
please make me host? Because I need to move people.
Oh.
If someone leaves the room, we need to have a way to pull them back into the lab.
Wait, I'm sorry, say that again?
Can you just make me host?
Oh, host. I'm sorry. I didn't parse that correctly.
Okay.
and
No
so,
problem.
oh, sorry. Do you do
Thank
git
you.
log 1 line to see what the commit numbers are before you do the checkout?
Yeah, you can write down the commit numbers, like I said, but you don't want to be doing that. That's an anti-pattern. You heard me talk about patterns earlier, right? A lot of what you do in programming is about patterns. You follow a pattern as you do a particular thing. And there's a term for something that you don't want to get in the habit of doing, and that term is anti-pattern. So
how do you know what how do you go back to 3 commits ago if you don't, like how do you find the number to it?
that is a good question. There is another way to do that specifically. So if you're staying on the same branch and you want to go back in time, you don't have to memorize the SHA, the unique identifier code. Instead, you can use a relative reference. Can you guys read that? I'm going to try writing that in another color. I need better pens. How's this? Can you guys read that? Okay. What this does is it says, check out the commit that is 3 commits behind head. This is go back in time 3 commits. Now, it's actually a little bit more complicated than that because sometimes you have more than one parent commit of a commit, like if there's a merge. Mm-hmm. And so there's actually two different commands, one that uses a tilde and one that uses a caret, I believe. And so in that one kind of situation, they behave differently. But that's rare. You're not going to be doing that most of the time. And usually what you want is the tilde one anyway. So just remember head tilde whatever. And that will allow you to move that many commits back in time. Now, it still puts you into headless mode, but you can easily jump back to the branch when you're done. And if you want to do work 3 commits ago, git checkout -b, new branch, and then just start working.
Okay.
So I'll run through this all together just so that you guys see the full workflow end to end. All right, so I'm here on master, right? Let me draw this in black. Okay, so here's master, and I'm here right now. And I decide, oh, you know that thing I did 2 commits ago? I actually wanted to do it. I wanted to do it differently. So, or last commit. I don't like this commit, but I don't want to destroy it just yet. I might want to try something different. So what I'd like to do at a high level is jump back in time to here, and then create a new timeline. Okay, so that's the high level description. What that would mean in git commands is git checkout head tilde 2 to jump back in time over here. Git checkout -b my new branch, or whatever you want to call it. And that creates a new branch on that commit called my new branch. Not only does it create the new branch, but it actually checks it out, which means that then if I write some code and then I do git add and git commit, because I'm checked out on that my new branch, that new commit is going to get added over here. So we've rewritten history and created a parallel universe in which this commit didn't happen.
Okay. So one more question. So earlier when we did git log one line where it gave us like a brief thing, it gave us the numbers and it said like first commit and second commit.
Yep.
Can you go back using those numbers if
Yes,
you don't know exactly how many commits you want to go until you see that?
You can always check out using the SHA. I'll say it again, you can always check out using the SHA. That is not a problem, but it's not usually what you want to do.
Okay.
So we can go backwards. How do you fast forward if you don't like this?
You can't go forwards. Each commit in Git is only backwards looking. That has to do with the way that Git is actually structured internally. So every commit can reference the commit that happened prior, that it's built on top of. But it can't reference commits that come later. So the only way to go forward in time again is either, Kelly, to jump to it directly using the SHA, or to check out a branch. Okay.
Sorry. Okay. So if you want to move, leave the new branch and go back to master, what is the git commit that you need git command.
Git checkout master. That's it. Just like any other time that you would want to go to master. Okay, so this is branches. This is all really that there is to branching, almost. Almost. Because there's one other thing that I haven't talked about, which is merging. Ooh. Okay, so let's say that I wanted to merge this branch into master. So I went back in time, and I created that new branch. Actually, conventionally, I would show that commit as being over here, because even though it's the first commit on that branch, it chronologically took place after this last commit on master. So, like, if you imagine the arrow of time, this is a more recent commit. That's a common way to draw this. You'll see that even though it's like more recent, it's older commit-wise, but it's more recent time-wise. So we'll draw it over there. Okay, so let's say that I wanted to take this, and instead of calling it my new branch, I'm going to call it my feature. You know, I went back to a prior commit, and I started working on some stuff that I want to integrate back into the rest of my app. Okay. There are a couple of different ways to integrate that. We are only going to look at one of them right now, which is merging. When you do a git merge, one of a couple of different things happens. There's an option called fast forwarding. So if I had hypothetically made this my feature branch off of master, and then I jumped to master and I said git merge my feature. That's one thing to remember about git merge. When you merge, you list the branch that you want to merge towards yourself. Sorry, not branch. So if I'm sitting on master and I want to merge my feature into master, I would be on master, and then I would say git merge my feature. That would be the command to merge my feature into master. If I'm on master. Merging is always towards you, wherever you are. Okay. If I had this commit over here.
Quick question there. Git merge is going to merge back to the master, which totally makes sense. But what if I wanted to take master in the direction of my feature?
You mean if you wanted to incorporate master in my feature? Like more recent stuff?
Then from the master, we just have to pull.
Not pull. Pull is repo to repo.
Okay.
You could merge master into my feature.
Okay.
And that would incorporate the more recent stuff from master into my feature.
Okay. And my feature comes later, so technically this git merge my feature. My feature now, that spot is the new master. After that command.
So in this particular case, the only difference between my feature and master, like they're in a line. My feature is a future version of master, or master is a past version of my feature. So Git will do a thing that's called fast forwarding. Instead of actually doing anything fancy, it will just say, okay, master now points to my feature.
Okay.
That's the simple case for merging. So if master is behind it, and if it's only behind my feature, then it will just move master to my feature. Okay, but there's a more complex case. Let's say that there are a whole bunch of commits on this. If I were to describe the relationship between my feature and master, I would say that my feature is 2 commits behind and 1, 2, 3, 4 commits ahead of master. You've probably seen this when you're like pushing and pulling from repos. And you probably wondered, how can it be both behind and ahead?
Yeah.
This is how. It means they have different commits on their branches. Okay, so in this case, I can't just fast forward. It's not possible because they're not the same history, right? So git merge does something different in this case. It creates a merge commit. A merge commit is a new commit.
Yes.
It's a new commit. That incorporates the code and the changes from my feature. And now master points to that last merge commit.
That's just crazy.
Yeah. Yeah, it's crazy, but it works. This is a very specific pattern of doing things with Git. There are other patterns out there. There's another tool that I don't know if we're going to cover it in Unit 3 or maybe not at all, but it's called Rebase. And you can use Rebase to do other things with your branches, to like basically pick them up and move them around. Or you can use other Git tools like cherry pick to like copy over individual commits from one branch to another branch. But these tools are more advanced, and if you don't know what you're doing, you can cut your foot off. So don't model with those for now. One of the nice things about merge is that, strictly speaking, it's not destructive. You're never destroying any commits. You're never destroying any work with merge. You're maybe making it harder to get to, and maybe you're going to introduce merge conflicts, but you're never destroying work. You're never breaking things with merge. Whereas with Rebase or with cherry pick, more so with Rebase than cherry pick, you can seriously break things. And you can also not only hurt yourself, but hurt other people who are working with you, which is very, very bad. But this is branching and merging. This is it in a nutshell. Create branches, write code, merge them in. And you guys understand what merge conflicts are, right? A merge conflict would happen is if we're trying to make this merge commit, and for whatever reason, both the two different versions, the one on my feature and the one on master, they disagree about the content of a particular line in some file or set of lines, then there's a conflict. Git doesn't know by default which one you want to keep. So the merge conflict process is really the merge conflict resolution process. Git says, I don't know which version of these you want. So here's both options. Choose which one you want each time that there's a collision, each time that there's a conflict. So the way that it does this is it writes some characters into your file, and you have to look for those characters and say, okay, version 1 is this one, version 2 is this one, I want to keep version 2. But you make all of those decisions. That's what resolves the conflicts. You delete all the extra text that get created, and then, yes, ooh, very good. Yes, that's right. That's what a merge conflict looks like. So what you would do is you would choose which one, either above the equals or below the equals, that you wanted to keep, and you would delete everything else. Delete the other version and delete the stuff with like the carets. But the carets actually tell you which version is which. So the one with the carets that says head, that's the version where you are. That's the version on your current commit. And the other one is the commit that you're trying to merge in. And that's its SHA right there. So merge conflicts are not evil, but they are a bit of a pain in the neck. They're kind of annoying. So generally speaking, you want to avoid them wherever possible. And there are a number of strategies you can employ to avoid merge conflicts. One of them was mentioned in this morning's diagnostic. Try not to touch the same files at the same time. Kind of implicit in that is break up your code across multiple files. That way, you're less likely to touch the same file at the same time, right? There's reasons. So yeah, that's all tied into that, and wanting to keep things, insofar as you can, separate, so that you avoid merge conflicts, and also that it makes it easier to hunt down bugs if and when they come up. Cool. Final question before we leave the breakout room.
Sorella, you can go first.
No, go ahead.
Oh, well, I just have a question for myself. I'm having, for some reason with the homework last night, or right now, I can't do the git push origin master. Is there anyone who could like stay on and try to fix it for me after class? So I can like start my homework and actually save it?
Yeah.
Okay, thank you.
Yeah, there are a number of reasons why that might happen. It's probably a merge conflict. And for whatever reason, your local version and your origin, your fork, got out of sync in this way, right? Where there's commits that are unique to the fork and commits that are unique to your local version. The commits, unique to your local version, that's to be expected. That's where you're doing work. But commits that are unique to your fork are ones that you want to try to avoid. And that can happen by doing things like if you use GitHub's drag and drop feature to like drop files into the fork, that will create a commit that's unique to the fork and isn't present on the local version. And so that can lead to merge conflicts.
Okay, what does git add period, or I think it was period space and an A or something like that does?
Okay, git add is what allows you to choose the changes for the commit. Every time that you make a commit, you're saving stuff. But you don't necessarily want to save everything every time. So the purpose of having a staging area is that sometimes you can save some things, but not other things. When you're going through the process of git add, you're choosing which things to save. And then when you do git commit, that's what actually does the saving. So git add is a selection process.
Because I think I forgot to, when I did the first time, I did git add, and I think I forgot to put the name of the file, and okay. I got this error on my terminal, and I start reading, and it say, did you mean to do git something and give me the period and an A somewhere? And I'm like, sure, I'll do that. And when I did that, I sent everything. I'm like, okay, I guess this is
right.
working.
So git add dot says git add every single thing in the present working directory, and that's because when you do git add, you either give it a file or a directory as an argument. And it will either add the file or add everything in the directory. And if the directory that you specify is your present working directory, then everything in your present working directory and everything inside things that are inside your present working directory is what gets added.
Which is not necessarily bad if you are completely done with your work.
Right, it's not necessarily bad, but there are dangers that can happen with that, and it's generally speaking something you want to try to avoid doing, especially if you're at the root of your project. If you're not at the root of the project, it's less of a big deal, but when you're at the root especially, you'll often find that there are a lot of sensitive files that live there.
Okay.
And you want to be very, very sure that you don't commit those, or you'll get an angry letter from Amazon, which you don't want.
Okay, great. Thank you.
Cool. All right. I think breakout rooms are closing, so I'm going to stop the recording.